A very good evening to all of you. So today I'll be performing the simulation of the asynchronous counter using Logic Circuit Simulator Pro. So before starting with the simulation, first you need to understand the counter. So counter is going to count the number of events. The counters are of two types, that is the asynchronous counter and the synchronous counter. So asynchronous counter is like a ripple counter. Like to take an example, if you throw a pebble or a stone in a pond, so what is going to happen? So there will be a ripple at the center, and that ripple will get transferred to the next level, and ultimately it will come to the corner or to the edge. So similarly, in this asynchronous counter, the output of the first flip-flop will be acting as the clock for the next flip-flop. So first flip-flop will be activated first, then the second flip-flop and the third flip-flop. But in case of a synchronous counter, all the flip-flops will be clocked simultaneously. It means that you will have to provide the clock to all the flip-flops. Now, if you want to build a counter, you need to have a flip-flop, and for flip-flop, you need to have the clock. This is the main difference between the flip-flop and the latch. Latch doesn't require the clock, but if you want to change the operation of a flip-flop, or if you want to change the bit of the flip-flop, then you need to apply a clock. Now, clock can be a pulse triggered or it can be a edge triggered. So before starting with this, we'll first place all the components in this main window using this component tool. So when you click on the component tool, so you can see here you will be having the flip-flop, so we'll be clicking on it. Suppose if you click it once, so then JK flip-flop element will be added successfully in the main window. So I think you will have to click two more times. I think we have clicked. So now you need to drag here. Now if you just click, I think you have selected only one. Single will be selected. Now again this will be selected, and again this will be selected. Fine. I think you need to provide a proper gap between the three flip-flops. Now you can see here, just by looking at the JK flip-flop, there are two inputs and there are two outputs. The outputs will be the main output, and this one is the complementary output, and one of the output will be acting as a clock for the next flip-flop. Now you can see here, preset and the clear, these are the asynchronous input. They are nothing to do with the clock. Suppose if you want to set your flip-flop before starting the flip-flop operation, you can go for the preset. And if you want to clear all the outputs, then you just have to provide the input to the clear. So coming back to our JK flip-flop, you can see two inputs are there and two outputs are there. So for the output, you need to add some outputs from the component tool. So the light, I think three light will be there. Then the switches, fine. So I think now you just have to place it properly. I'm placing it here. Okay, I think just bear with me. Okay, I'm placing it here. Now this one I am placing it here. uh, okay, this is okay. Now you need to make the connection. So when you will have to make the connection, then you need to click on the connector. I think this is one will be okay. So if you want to make a connection, you just have to click on this 2 points. The connection has been established. Now similarly, this one, okay, the connection has been done. I think you need to shift, okay, because we need more space here. Similarly, okay, I think it is good. Okay, so now the output of the first flip-flop. Now in this case, I'll be taking what? I'll be taking the complementary output. Okay, I need to provide a space. Okay, again, right. Now what about the inputs? So I think there is one condition in the one condition in the truth table that when j will be equals to k will be equals to 1, and if you are providing a clock, then the output is going to toggle. Now, what do you mean by toggle? Toggle means that every time if you are applying the clock and if your inputs are 1, so then output will change its state. The 0 will be changed to 1 and 1 will be changed to 0. So I think this is the thing we need to provide, right? I think this j will be equals to k will be equals to 1. Right now they are at 0. Okay, so this okay, I'll just give. I think it is not connecting properly. I need to go for a connect. Only then the first input is selected. There is a problem with this. Okay, it has been connected. It took time, but I think right, the connections has been done. So I think we need to start the counter. But how can we start? Because the first flip flop is not clocked. Yeah, this will be the clock of the second and third are coming from the first and the second. But what about the first flip flop, where the clock will come from? So I think in that case, we will have to go for a generator. I think this will be acting as a clock, and this is 1 hertz. So this is there. Okay, the connection has been made. So now we can start our operation. I think I need to uh, go for right. It is okay. Touch. It is okay. Just one. Right. All three inputs are one. So you can see that this is what right, 0, 0. Now all the inputs are 0, 0, 1, 0, 0, double 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, triple 1, and again 0, 1, 2. This is the MSB bit. This is the least significant bit as compared to this bit, and this is the least significant bit. So this is, you can say, I think B3, B2, and or you can say B2, B1, and B0. So 2, 3, 0, 1, 0, 0. You can say 1, 0, 1, 1, 1, 0, triple 1. Again, it is counting. It is counting. You can have the counter in the increasing order, in the decreasing order. You can have the synchronous counter. So I think you can do all the variations. Suppose what will happen if I give the main output to the clock? Just check it out. So I think this is all for today's class. We'll meet. Will meet with the next assignment. Okay, so till then, thanks a lot.